Well, hi and welcome to my shop, and thanks so much for joining me here today. It's March 15th, and I'm in the midst of a difficult project. It's going to get a little more difficult, and I decided today I would do something a little easier, and I'm going to work on this signal tracer which someone was kind enough to give me, rather than throw it in the garbage. What a shame that something like this got tossed in the garbage. So it looks a little rough. I mean, the rusty plate here is screaming out ugliness, but that can be fixed pretty easy. And has a magic eye. It's a signal tracer Heathkit. I don't see a number on it. Oh, there we are. Model IT-12. Yeah, hello Shadow. Thanks for coming and joining me. Keeping me company here in my shop. Right. So, output transformer. Oh, this is interesting. B+. Oh, what's all this? This has got to be the audio level. Output transformer. So, I'm going to take a wild guess that you could connect the output of a radio to these terminals and skip the output transformer that comes with the radio. There's one inside here. I think that's what that is. Speaker, so if you want an external speaker, I guess you hook up here. If you would want to do that. Or maybe this is direct access to this little speaker. I have not looked at the schematic yet for this or anything about it. Now it has this very... This is audio this way. What's this other way? The other way is rubbed off. Would it be RF? This doesn't do RF, does it? Noise, speaker on off, main on off, and level. Yeah, I think this is just an audio. So I don't know what's over here. Inside here, though, I believe is a vacuum tube. Very good. Okay, step one. I'm going to take and open this up, and we'll see what's up with it. To service. So a lot of things changed for me in the last few days. On Thursday, I got a phone call from my doctor's office. Saturday. Today is Monday, I think. Isn't it today Monday? Today is, I'm not even sure. I think it's Monday. So I got a phone call from the doctor's office. Saturday, I got vaccinated with the AstraZeneca vaccine, first shot. Totally surprised. Not expecting that for a long time. Really until August, I was thinking. So, stunningly enough, the thing about it, and you might as well hear this, is it made me a little bit sick. Or, you know, my experience. It's just anecdotal, right? Got the shot. That evening, I was feeling a little bit headachy and a little bit achy, just a little bit. Like a very mild flu. No cold symptoms of any sort, like no cough or anything like that. When I went to bed, I couldn't sleep. And I spent the whole night restless. You know how that goes. You're pretty sure you didn't sleep. I probably did sleep an hour or two here and there. During that, couldn't sleep. Woke up with a worse headache. Still, not bad. Not a terrible headache. Okay, I know about terrible headaches, let me tell you. Took some Tylenol, kind of went away, and then yesterday, just during the day, I got better and better until by the end of the day, I just felt pretty normal. Today, I feel pretty normal again. So I think, you know, I would say to somebody who's going to get the AstraZeneca, and maybe it's true of the other vaccines too, be ready for a sluggish day afterwards. That might be the best thing to say. I would never discourage anybody from getting a vaccine. Okay, now, let's take a look at this guy here. Oh, my next shot? Somewhere between now and 16 weeks. That's what I was told. So I'll bet you it'll be about 6 weeks or 8 weeks, I bet. So we had a Pretty big tube here, 3 tubes in this guy. Oh, this is the I tube. What am I saying? Pretty big tube. I tube, big transformer. Componentry looks really good. There's one molded capacitor there. You know what? And I think that's it for molded capacitors in here. Just one. Just looking all the parts over. So, you know what? This guy's ready to be plugged in. There's no reason not to. Especially because here in my shop I have ways of controlling the power going into something like this. So I can keep it, if there's something seriously wrong, it won't cause a serious problem. Let's just take a look at the cord. Yeah, it's good. Okay. Should turn the level down. Speaker, we should turn the speaker on. Woo, a little dusty. Noise. What's that? Noise. What is noise? What is a noise switch? Well, I'm not sure what that is. Noise. I assume it's noise off this way. Switch off. And we need something to test. What do you think, Shay? What do you think we should test here? We need something to test. Oh. Well, I guess I can test the output of a signal generator. That might be a good start. I got lots of them. Okay, that's good. We're ready. Okay, that's power on. Now we're going to go through the dim bulbs here. Just the one. Ready? Okay, dim bulb behavior is okay. So the supply voltage here is a surprisingly low 87. We'll only have one light in, that's right. Okay, we've got some sound. So that's telling me there's a big filter capacitor here. I didn't really notice it before. This guy's probably spent. Anything else happening? I see no tubes lighting at all. That's a little surprising. 80 volts. I think I'd see something in here. So I can see the magic eye is partially lit. That's interesting. One tube is lit, quite brightly back there. It's a little hard for you to spot it. The other tubes don't appear to be lit. Well, the one other tube. Okay. Before I get myself in trouble here. This tube here is not lit. At all. Surprising. Okay, power off. So out of that we get the hum. The hum is probably this capacitor. The unlit tube. Wow, it's really jammed in there. Maybe it's just a connection here. So this is pretty rusty. It indicates some moisture. I mean, look at the front panel. That's certainly indicating moisture too. This is a 12AX7. That's got 2 heaters in it, and neither one of them seem to appear. My light is flickering beside me. Wow, it really goes in there. Hey, flickering light. this again. Huh. I don't think it's lighting up. Power off there. Just take it back out. That's kind of surprising. It's really quite surprising. Okay, we'll have to test that tube for sure. We really got to deal with this guy first. A little tight in there. So what do I see? So I see there's 3 ratings up here. 25, 30, and 50. 25. This is 25-65. Don't really know what that's about. 30. Wait a minute, I'm reading this wrong. 30, a 30, and a 20. Well, I think we can guess. It's 150, 150, and 25 volts. Hard to see there. Let's take a better look at it. Yeah, you take a look there, Shadow. Well, that looks like the letter A at the top there. A, 25, 55. Synchro. Okay. The ratings are 30, 30, 20. Yeah, 150, 150, 25. And then just like a serial or a warehouse number or something at the bottom there. 85, probably 85 degrees C is what that last part says. What's this top thing? Synchro. What are they talking about? 825 to 65 synchro. You got me. Looks just like an ordinary capacitor to me. And the leads underneath. Try to find out how they've done the ground lead. You see 3 terminals that are the positives, and then where's the ground? Is it just the bolting? This really isn't even bolted. Is it bolted in? Oh yeah, it's got a bolted in bracket. Maybe that's it. Usually they've done some soldering thing here. Oh, that red wire. Ooh. Is that red wire going where it looks? It is. The red wire is going to the chassis. Well, that's kind of backwards. And the black wire, no, not a black wire, it's just a resistor with a black covering going to the positive. Why would they ever use a red lead on a negative? What are they, crazy? Oh. Oh. Well, I'm not going to say too much until I get the schematic here. There's definitely a few things rolling around in my head about what's going on here. Yeah, I should get the schematic. There's that one capacitor. All the rest are probably okay. That one's probably okay too. there's the speaker leads. Look at that one's grounded. Well, how many times did they ground it? Well, that's grounded every which way. Okay, so that's a grounded one. Doesn't say anything on the front. Just says speaker. Should have a ground symbol there. You need to know this. The other one, of course, is the lead. So through these two terminals, you get direct access to the voice coil of this speaker, if you wish, or whatever the speaker is being driven with out of this little transformer here. There's the 3 wires. These probably go right back to those terminals. Yeah, I got to get a schematic here. Let me stop and hunt down a schematic. Well, I finished reading up the user manual for this device. I'm a little excited about it now. It has a feature here, this noise feature. It's very interesting. When you flip it to noise, it puts a voltage on the probe of about 100 volts. No current behind it, so you can't get a shock or a bad shock, but 100 volts. And you put that through a component. And if there's if the component has problems which might cause noise, basically loose connections, basically, it should show up in the speaker, according to this. Very interesting. Never heard of anything quite like that. Never seen a testing device that, well, an ohm meter, but not like this, puts a voltage onto the device it's testing. That's very interesting. The other thing about it is, this is an untuned signal tracer. I have a tuned signal tracer sitting right here, which I use fairly regularly. But you know, it's problematic using this because you have to set the dial and set a lot of knobs, all that kind of stuff. This guy is actually would the right word be antithesis of that? He's made to be really simple. So it will do RF, audio, and RF. There's no tube inside here. It's just a diode. It's really quite simple. I don't know why they need such a big thing, but they got a big thing here. And it'll just basically amplify whatever you put onto the front of it, RF or AF. And you can also use it as a separate speaker. If you turn the speaker off, these leads go to the voice coil of the little speaker that's in here, and they don't go anywhere else once the switch is off. So this becomes a bench speaker. Hey, I need that because I'm forever needing a spare speaker on my bench. So now I have one I can access. So kind of neat. The transformer connections here, I'm not quite sure what they're suggesting here with these. One thing I did read is you can put a voltmeter on the plate terminal here, and you can read the voltage on the plate, which helps you in some way. I don't know what way, but somehow. There we go. So, yeah, I think this guy is well worth bringing back from the dead. Now, the hum we heard. Of course, if we don't have a tube in here working, really whatever we're hearing doesn't make a lot of sense. So why don't we start right off with the testing of this 12AX7 tube. Yeah, 12AX7. Okay, I'm going to set up my tube tester here, and we're going to test it right off the bat. Okay, we're ready here. Let me just double check the settings. I've already set them, but let's double check them. 12AX7 6.3 2 18L. Have to be so precise. PGK77. PGK77 3516 3516 47 with an F. Okay, we're good. Notice it's a 6 volts on a 12 AX7, and the idea there is there's actually 2 separate heaters in here, which is curious to me about why it didn't appear to heat up. 2 separate heaters, each one can be supplied separately with 6 volts, or you can supply them in series with 12 volts. It's your choice on how you want to make your gizmo, a lot of them are going to do it with 6 volts because that's what they have available in there. And this guy's not lighting up. I don't think it's lighting up. That's odd. Test would be here. It's 0. Wow, okay, well, appears to be what it is. They must share a common lead or something. I wonder if we can see in there. Is it hard that you can see? Yeah, let's take a look at this tube a little bit closer. Yeah, not all that stuff. Look at this stuff. Okay, I'm going to zoom in the focus here. I'm going to max it. Just give me a second here to make that happen. See if we can see right inside this tube, because there's quite a gap here. I can see lots of stuff. What's going on in there? Wow. So there we can. So there. Now we see the heater elements quite clearly. Oh, look how they're connected. I think they're spot welded onto the leads that are sticking out the bottom of the tube. Wow, this is one of the clearest I've ever seen. You can just look right in there. So two leads. No, you can see one of them is going to both heaters. This one in the middle. Sure seems to be attached. I'm going to rotate it around, and we'll look from the other side now. So now we can see the center one. It's attached to both. It comes down to this pin. Well, how can the pin not be continuous through there? So how do you get both heaters not working? Do you jam 12 volts onto a 6 volt heater? How would you do that exactly? There's no evidence that anything's happened to this tube. I mean, I'm not really sure what you would see in here. It's all covered up there. You usually can't see into these tubes quite so well. This one's a real open book. Just looking for anything that's like hanging open, although we've already looked at the heaters. So somebody probably manually made these welds on a small jig when they were assembling this tube. I don't see anything at all that looks wrong or bad. I'm going to put an ohmmeter on here, and we can see where these leads are going. You don't have to check in the manual. One is right back there. So one is, whoops, yeah, right. So one, if I go on this pin, goes straight to the heater, and then back here, this other pin back here, that one. And I put the ohmmeter on. I don't believe it. I don't believe it. I don't believe it. I don't believe you, Mr. Tester. And I don't believe you. Another tester. Let's see if I'll believe my own meter. 2K. It's going to be tricky for me to make the pin contacts here. So one of them was right here, and the other one was somewhere back here, right here. What's happening here? That's one of them. The other one. Can't see it. The other one is yeah, I could look in the manual, couldn't I? Just look in the tube book. So this pin versus that same one. Looks like the same thing. Okay, come on, get on there. Whoops, just a second, I didn't get a good contact. What's going on, Mr. Tube? 12, am I reading it wrong? 12AX7. No question about it. Then a bad socket contact. Or both heaters are, no, they can't be burned out. I just checked them with a ohm meter. Okay, so watch the light. We'll see if it dims as I put in the tube. Yeah. Yeah, it's going up and down as I wiggle the tube, so I got lots of socket problems on my tube testers. This is really strange. Did we get anywhere? Part 2. Part 1 and Part 2, neither showing anything. My tube tester's not that. Oh, it is lit up. Okay, it's lit up now. It's lit up. I touched it and it stopped. Okay, there it goes. Both sides lit. Both sides lit on this tube. It's supposed to go to 1,000, just over 1,000 here. It's way up here. It's like a brand new tube. Wow, it's a beauty. You want that in your guitar amp for sure. Well, then the same thing must be going on in the tube tester. It just wasn't getting contact. It's really kind of odd. It's really, this is just odd. Odd. Let's stick it back in there. Just goes to show that anytime you test something valuable like this and it doesn't pass the test, you need to stop and think, did that really work? Don't be throwing out things on one test. Okay, we'll try it again. We'll see what happens. I imagine it's just going to hum. Level down, speaker on, and this is on audio, and away we go. Plug it in. Still going through a dim bulb. Now this time, is it warming up? Okay, so again, the tube is not lighting. The tube past it's lighting. Why? Oh, wait a minute. Wait a minute. I think it is lighting. That's me touching the probe by accident. Well, if it's lit, let me switch to the close-up camera here. Can't tell which camera is which because they're both showing darkness. Okay, here we go. Now we're looking right at the tube. We're looking in the tube. It's just barely lit. Like, look at the one beyond here. Oh my gosh, it's a beaming, you know, ships could sail by that other one. But this one? So the blue light is coming from a little indicator light on my camera. It's being lit. That is so weak. With my eye, you wouldn't even know there's any blue light involved. That gives you an idea how weak the heaters are. Why are they that weak? They shouldn't look like that. And that other one really shouldn't look like a light bulb. Look at that thing, it's just glowing. You can't really see it that way. Something funny's going on here. Very funny. Ha ha. Maybe not funny. Ha ha. Okay, put some normal light on it, and maybe I won't be so... Yeah, with normal light, of course, the glowing tube looks normal. I'm just picking up my telephone here. I thought this thing was hummy. Where'd the hum go? Volume up. So now that hum can be just from the probe lead. I don't want to touch it, I just want to get close to it. Yeah, so you see the probe is just picking up a hum out here. In fact, let me do this. What if we do this? What if we ground it out? Oh, listen to that. There's not a hum there. There's nothing wrong with this unit. A little bit of dirt under control. There's absolutely nothing wrong with this guy. Except this tube. Well, maybe there's nothing wrong with that too. How would we... Now, the magic eye is so dull. Look, with lights on, we can't even see it. Oh, you know what? I don't have full power. I want full power. We're way down. Oh boy, let's give it this. Screwing in another light. That's gonna get my dim lights. That'll raise it up to 110 volts. So that's, man, the eye is glowing now. And it's a weird looking glow. Kind of weird looking. Let me just get the focus rate on the money here. I think I'm going to reduce the camera's brightness a bit. There. And you get a much better idea of what the back of this bulb looks like. The open part, the open wedge, the dark wedge is off to the left, like it's pointing at, what would that be, 6, 7, 8 o'clock? Shouldn't be there. The tube is probably rotated a little bit. Not that it matters. All the black specks on the back of the tube phosphorus. Can't say I've ever seen that before. Okay, let's give it a little signal here. Okay, volume's turned down, short, taken off. You're going to turn it up and just hear the probe noise. Ha! Look at that. I wonder if that's just dirt on that glass. No, it doesn't feel like it. Well, I mean, I guess that's working, eh? Not that you just... Let's give this thing a real signal to chew. Let's do that. Hey, I was looking for an easy repair today. Here's one, for sure. Okay, so we will use this guy. We'll reduce it. It's already putting out an audio level signal. And I just need a nice little piece of cable here. Goodness, I'm not going to be able to find it in moments. Okay, we'll do it another way. We'll actually use the probe. Now, before I touch this to a ground, right now it's in an isolated outlet. Let's do a little test here. I'm going to use this other instrument that I'm not that familiar with yet. And that's this guy. His output is being fed through some switches, through these lights, and over here. I'm going to feed this directly to this guy. That's going to give me a chance to make a couple of tests, special tests. Okay, so we need to unplug him here. Not a polarized plug. This is what I'm reacting to. Not a polarized plug. Pull this out. Okay, that's just my dim bulb system. We're going to plug this right in. Zoom. And he's going to get about 100 and he's going to get the usual line voltage now. So it's running on the normal line voltage. Now this guy has this leakage probe, which I'm very unfamiliar with it. But let's just fool around here. Only one way to get familiar. So it has two leakage switches here, a high side, a low side, and that's where the probe goes. So right now the meter is reading the output voltage of here. Switch this. It's now a leak meter that I'm not familiar with. It has a button here to push to read true leakage current. So I think this is a warning. I think they have it arranged like this so you don't push this button when you shouldn't. They didn't really say when you shouldn't. Okay, so we're just going to touch the chassis. I don't see a darn thing. Am I doing this right? I don't know. Let's push the button. What kind of button is this? Not much to it. Why the reduction of hum? Just a wild guess. You've got hum going into something, and when you attach the probe you get hum going here, and the result is this, a common mode result which isn't coming out of the speaker. I'm not seeing anything up here. Low side leakage. Okay, so does that mean there's no leakage, or does that mean I don't know what I'm doing with this probe? Push the button again. Well, according to that there's no leakage, but I've got no experience with it, so I'm really, well, I'll do what I usually do now. I'll take a voltmeter, high impedance voltmeter, and we'll just look for voltage between the chassis here and wait a minute, let's do this again. I'm going to flip this around. Try that again. High side, whatever that means. No movement on the meter. Nothing, nothing, nothing. I have to find something leaky to test. Okay, I drifted off into some stupid rant, which I am not going to publish. It was stupid. Let's do the voltage test. Why am I doing this? Because I am a chicken, because I learned the hard way so many times. There's no reason to expect a problem. That's when they show up. Okay, so from ground to ground, any ground, this ground. DC. 20 volts. Let's put it to 200. 200. Here we go. 30. Okay, I'm going to switch the plug around. Touch the probe. And what do we get now? 70. 30. Same voltage. So that voltage is probably a leaking over voltage through a capacitive connection, or very high resistance connection, maybe through weak insulation, transformer insulation, something like that. So this guy says there's no leak. This guy says there's a 30 volts, but it doesn't matter which way you reverse the plug, you get the same 30 volts, which is curious. I think there isn't the slightest risk of connecting this right to ground. Right to something that is grounded. Let's put it that way. I mean, there shouldn't be. I mean, that's what it's designed for. It's supposed to go onto grounded stuff. You're dealing with an old device here. I didn't really study it carefully. There could be a critical capacitor in there that's tying something to the chassis, and it could be a short, and it could be a bang, a big bang. Now, how am I going to make this connection up here? I'm going to have to stop and find that cord. I need that. I need a cord. Okay, got a cord. You know, one of the best channels to watch on TV is the NASA channel, NASA Space Channel. And the reason for that is all they show you are wonderful people doing wonderful things. Turn on almost any other channel and the programs aren't like that. Almost any other channel. And you know, it's wonderful to spend your time watching wonderful people doing wonderful things, even if it's from 40 years ago. A lot of it is on that channel. Okay, so we're going to now hook up. Hook up, hook up, hook up. Hook up. Nice. So I think there's a boop, boop, boop sound going. Yep. It's a lot more hum than there is whoop. This eye is not doing the right thing. I think it's reacting to the input level. Yeah, it's not. I think it's the hum. Yeah, something not quite right there. But it does work. Let's put it on to. I'll jack up this frequency way up. It's just doing the audio thing. Get way up into radio frequency stuff. Okay, it's way up high. 4 megahertz, 5 megahertz up in that range. Flip the lead here to radio. Well, that's not doing much, but there's not much output here. Let me crank it up. Ooh, actually there is. That's, well, it's not a very strong signal generator. Sounds like a nothing to me. What would I be expecting to hear? I think there's a detector, and I think we'd be hearing the audio. Not sure of that. Okay, let's turn this up. Yeah, this indicator is not going to help. And turn this up and down. It makes no difference. So pretty inconclusive on that. What exactly is going on there? The audio. I put on audio. this back down to audio frequency. Hello. Oh, I think I turned this right down. Oh, that was dumb. Back up to radio frequency on audio. That's just a speaker switch. Can't be responsible for anything. Okay. Well, we got what we got. Let's try. Now, do I have a component we can do this noise test on? Well, I got lots of stuff here, but noisy stuff? I don't know of any noisy stuff. I don't know of any noisy stuff. How can I test a noisy thing? A noisy tester on a I don't know. Well, we can test for the output voltage and see if the 100 volts really does show up. Should be 100 volts here now. DC hooked on. Audio switch. Wiggle the noise. Looking for 100 volts. I think it's bonkers. Put it on RF. Look for the 100 volts. Wiggle the switch. Would appear to be bonkers on the 100 volt thing. Has a couple of problems now. Works on audio, doesn't seem to work at all on RF. Has a bit of a hum, but it's hard to say whether that's normal or not. Okay, time to stop and think a bit about what to do next with it. I am very much interested in getting this noise thing working because it's a whole new way of testing stuff. And wouldn't hurt if this worked. It's quite useful. Yeah, I think it's worth the effort for sure. Hum in the power supply. Let's take a look right now. So what we can do is simply take a voltmeter, like this kind of voltmeter, put it on AC, see what AC voltage there is on these capacitors. If they're doing their job really well, we get a 0 here. Well, that's no 0 there. That's no 0 there. Third one. That's probably the bypass one. Is that Peanut I hear behind me? Is that you, Peanut? It's a beautiful sunny day outside, but quite cold, right around freezing. They look outside, they see that sun, they see the spring, and they see my neighbor's chickens. Yes, my neighbor has chickens here in the middle, basically the middle of a city, middle of a suburb in a city. They like the chickens. We like them too. Okay, yeah, I'm going to stop for a bit and ponder this. I have to go play with my cat here. Is it really you? Yes. I know the situation. I know. Hey, Peanut. Hey, Peanut. Peanut, do you want to go out? Yeah. I don't need to ask. I want to go out too. Yeah, we'll stop for a while. And clear my head, make my cat happy. Yes, I'm coming. Okay, I think what I'm going to do here is take some voltage tests of the unit while it's operating. Up on the schematic there are voltages. Let me zoom in more on the power supply. We'll start with the power supply. See what's happening there. I see 138 volts here, and on the other side of the 10K, 114. I think that's it. Those are the two readings. Okay, power on here. Using this meter, set to 150 volts, and we're going to go after why so different? Why so different? What happens if we just reverse this? Now, what happens if we ground this to give me a good spot here to clip onto? Here. It's a little better. So now the hum we're hearing is really coming, I believe, from the test probe, which is just out here. Yeah, who knows? You know, this thing's in such a state that. Oh, where'd it go? Okay, let's get on with the voltage readings here. DC. I'm going to go right on this capacitor. If we look at the power supply diagram there, the two capacitors, two of them anyway, the two bigger 50 microfarad are going to have, it's 150 volts there. Just a small voltage there, so that's the bypass. And then up here. So that's 120 on my meter. Oh, son of a gun. How did that happen? How'd that happen? Let's try that again. Good to do things twice anyway. So that's 150 full scale there. And 125, so we're supposed to get 138 and 114, so it's a little on the elevated side here. Why is that? So we're supplying it with 117 volts, the usual supply level. Well, getting more than you bargained for. That's not so bad, is it? We don't know if there's a hum in there, and maybe that's throwing the meter off also, but certainly voltage is there. I think I should get my other tracer going and we can listen to the hum on there. It's tricky, it's all uncalibrated and a very sensitive instrument, so a tiny amount of hum can be made to sound like a freight train if you just turn volumes up. So it's not the best approach. That doesn't lead to too much certainty. You know what would though? If I put it up on the scope of the voltmeter should do the trick. What did I get here again? I got the full voltage here, didn't I, last time I did this? I got the full, or nearly full. Okay, so this meter is on 200 volts AC. Let's just make sure I'm having a lot of trouble with this. More and more trouble all the time with that guy. Shouldn't do anything. Reading to chassis from, let's start here, 1.6 volts AC and 150 volts here. So well, that's roughly 1%, wouldn't it be? 1 volt in 100. 1% hum here. And this other terminal, even lower. Let's have the volume turned down right now. We don't hear much hum. It's always a little bit of hum from these guys. It's really no hum. I think the power supply is okay. I think the filtering is okay. So let's take a look at some plate voltages, or what else is on the chart. Let's just follow the chart here. So we come up this way. We should get 130 on pin 7 of that tube. That tube is on the other side. It's the one down there. Oh boy, how am I going to get to it here? Just put this thing right on its face. There we are, that beaming tube there. That just doesn't look right. You can't, yeah, you can see it in the camera. It's just beaming. The pin we want to get on that tube is pin 7, and we expect a plate voltage of 130. Pin 7. So 1. So pin 7 is, that's how many pins there are. There are 7 pins. So this is pin 7. This be it. 140, and the expectation is 130 on the chart. Okay, again, just a little high, but it's there. The screen is on, looks like pin 5, 114 volts. Pin 5. Wait a minute, maybe it's not pin 5. I don't think it's pin 5. Pin 6. Pin 6 will be right here. And we see 120 something volts again. It's higher than nominal, but in the right ratio with the plate voltage, so I don't see a problem there. Now we should see 0 volts on pin 2. Zero volts on pin 2. Okay, so pin 2. Pin 2 is here. See no movement on the meter at all. 0 volts. And that's proving the blocking capacitor up there is working. Some sounds coming out of it. Okay, so if we go over the 12 AX7, it looks like 2 different voltages on the plates. Pin 6 and 1. One has 80, one has a little less. Pin 6 and 1. Pin, it's a little tough to get in there. This is a 9-pin tube. So counting back from what I think is pin number 9, 9, 8, 7, 6. So this would be 6 right here. And what are we expecting from 6? We're expecting 80 volts. 80 volts, and I'm on the 5 volt scale. Ooh. 150 volt scale, 80 volts. Ooh, scare me. And it's just above 80, about 90. Okay, so that's correct. They're all a little high. 76 on pin 2. Okay, pin 2 is going to be a little tough to get to, I think. Pin 2. You may not get in there. Just a little bit tricky to stick a probe down there. Maybe from up here. There's 1. There's 2. Oh my gosh. One, there's 2. Anybody looking at the meter? Oh, jeepers. Very daring here. Once again, pin number 2. Got it in my sights. I don't think I'm getting down to it. I think my probe is getting hung up on something. that's it. There's nothing going on the meter. Okay, double checking. I'll look at the schematic again. And am I looking at the right tube? Maybe I'm poking on. No, I'm looking at the right tube. It's definitely pin number. Oh, what happened? How come I said 5? Did I say 5? It's pin number 1. 1 and 6. Where did I get 5 from? 1. Okay, so where did I get 2 from? 2. Why was I thinking 2? I don't know. Pin 1, well, that's even harder to get at. Pin 1's got a capacitor hooked up to it. Pin 1. Oh. Oh yeah, 0.05. That's probably it. Pin 1. Pin 1. I think this is pin 1 here. See, 85 volts. Well, it's the right ratio, right? 85 and 90. So that's okay. So look at the cathode of the amplifier tube. So that would be back to pin number 1 should have 6 volts on it. On the amplifier tube. This guy here, pin number 1, looking for 6 volts. Let me go back this way. 6 volts. Okay, we're on a 15 volt scale now. Pin 1 is kind of in the back there. White wire. The white wire comes up, goes way over, and disappears. I can't follow that. Do directly to pin 1. Here we go. Pin 1. We see 7 volts on there. That's good. Okay, so that means the bias is correct on that tube. And I did check the screen. Let's go back to the 12AX7. The grids should have a slight negative voltage on them. 7 and 2. Oh, there's 2. Right, I know how to do 2. 2 is supposed to have a little tiny voltage on it. 2 should have minus a half a volt. Well, that should show up. Minus half a volt. That must be grid leak type biasing there. Oh, it's got a capacitor blocking B+. Yikes. Okay, number 2. That's an interesting one. And number 2 is the one I gotta go down to get to. There's a wire on it. Where's the wire go? Can I follow the wire? The wire comes up to just as difficult to spot. Oh, it looks like it. No, that can't be it. It's not a wire, it's a resistor, that's why. Okay. Everybody get that? It's making scratchy sounds, but so we're on the plus setting, 15 volts, and we're looking for a very small voltage to go lower. 5 volts now. Very small voltage on 2. Okay, going in there. Going for 2. 2. Negative voltage. It's a grid, so it might make some noise. Okay, so there we are, 5 volt scale, and we're looking at a little over half a volt, negative. That's exactly what it's supposed to be. And pin 7 should be negative much less. Pin 7. Pin 7, that's how I think that might be out of reach. Let's see here. Pin 7. Well, it looks to be grounded. Why am I seeing it grounded? That doesn't make sense. Pin 7. A resistor and a capacitor hooked up to it. Why? It must be that right there. Nine, 8, 7. This would be 7, wouldn't it? No. I guess I just can't see the... There we are. That's it. There's the resistor, there's the capacitor. Very, very small voltage showing up. Oops, 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 oops. 1.5 volts all the way now. Negative. And we get 0.1, a little over 0.1. 0 is good. 0.1 is just, yeah, that's good. It's all coming out just the way it's supposed to be. The unit is working perfectly. There's nothing wrong with it. Okay, let's go look at the magic eye now. Magic eye was kind of working, but it didn't seem to be behaving the way you'd really want it to. So these things usually have a 1,000,000 ohm resistor in them. There it is right there. And often that resistor is bad. But let's start with B. Well, we know B plus must be on there. We should get on pin 4. Pin 4, we should see 140 volts almost. Pin 4, so count 1, 2, 3. Here's pin 4. And no, not 5. That's the beauty of using these meters. You can't blow them up. They sort of self-protect in a way. 4, 138 should come almost full scale here. Well, I didn't go for. Hey, what's this doing over here? Have I been making all these measurements without the meter ground connected? How? How can that be? Okay, whoa. Over there. It shouldn't have worked. Let's go right back to the B plus test. Where'd those capacitors? Where'd that capacitor go? Just pick one, any one. Okay, so that's on the 500 volt scale. 150 volt scale. I read 150 without the ground connected. So it must be. That's a tough one for me to explain. Oh, I know what it is. So I connected the ground over there to knock the hum out, and that's created a ground connection that's the same as this. Same as this guy. It's just a little circuitous around my shop. Okay, that explains that. Mystery. Now back to what we're doing. So we're looking for the voltage here. We're getting 150, and on the chart it says 138, and that's everything's going a little high in here, so that's okay. On the other side of the resistor we should see 15 volts. Oh yeah, so we'll go on the 50 volt scale. 15's about there. 15's about where? 15's about there. Other side of the resistor. 15. Right on the money. What else can be going on in here? Do we have any? We have another voltage showing to us of minus 0.4 on pin 5. Minus 0.4. Pin 5. 1, 2, 3, 5. 1.5, 0.4 is just a hair over 0.4. So every voltage is coming out correct on this. Is there any reason why I should be suspicious that the filter capacitors are not filtering at this point? Why would I think such a thing now? That's a good way to get a shock, is moving these things around on your bench. I think it's 100%. Now we tried getting the 100 volts on that probe and we never got it, so why don't we fiddle around with that? So the 100 volts, all I gotta do is just clip this to the probe here. And we can watch the 100 volts on this meter here. 100 volts. 100 volts is about here. 100 volts. Nothing showing up. Maybe I read the manual wrong. Maybe I read the manual wrong. I'm going to reread the manual and try to figure out how you're supposed to see 100 volts on the end of the probe there. How's that supposed to work? And this is only the schematic here. Yeah, I'm going to stop and read it again. Okay, I think it's time to understand what's going on in the probe. Now, at first I thought there was a vacuum tube in here, but there's nothing in here. A switch, a diode, and a capacitor. So when you have it on RF, you're passing through this diode, so you're detecting already, and I think you should hear the program material in the RF signal that you're attaching to. There's no modulation. I don't think you'd hear anything come out the speaker. Now, if you flip this switch to here, you're just simply bypassing this stuff. It's just a straight out, straight to where? Straight to, oh, there's the noise switch. Interesting. Straight to the volume control. Straight into the volume control. And this is a grounded line here. Very, very simple stuff. Now, the noise switch closes. I'm supposed to stick a voltage, so they're getting the voltage from, oh, they're getting it right out of here. Well, that 68,000 ohm resistor is what's keeping this from being dangerous. So if you touch the probe and ground yourself back to the chassis, you only draw a small current to get a small shock. And it also protects the rest of the circuit too, so you can never draw a heavy. So that's pretty straightforward. Close the switch, and you pick this voltage up and stick it right on there. Now, why wouldn't it show up? Let's look for voltage on the noise switch itself. Voltage on the noise switch. The noise switch. Let me just use this guy right here. He's not doing anything. Let's give him something to do. So we'll go on the chassis here. And back of the switch, and we're looking for well, it's there. And what about on the other side of the switch? It's there. We open the switch. Still there, but not there anymore. So close the switch. Voltage is being sent to the probe. Am I just reading it wrong? Probe. Hey, it's there. Why not get it over here? Why not? Why not get it over here? So we're still hooked up here. This is still saying nothing. Come on, you gotta say something. Bad clip lead. Huh. How do you like that? You know, I can't keep ahead of my own clip leads. these for resoldering. Okay, let's get a good clip lead. Give me a good one. Pretty sure this is good. Isn't that something? A clip lead's going to throw you off like that. Now we're cooking. Okay, we got the 100 volts. So there's nothing wrong again. Nothing wrong again. That's fantastic. How about a noise? What have I got that's noisy? Have I got anything at all? I got nothing that's noisy. What have I got? You know, if it's noisy, I've thrown it out. Well, let's check and see if something is not noisy. How about this resistor? Is this a not noisy resistor? So we would hook it between the ground Well, you know what? This is a great demonstration of what happens if it is noisy. I got the volume turned right down. So that's the whole idea, though. What happened to the noise? Okay. She's a-working. All around. Okay, come off of there. Come off of there. Power off at this point. I think I'm going to turn my attention to this ugly plate and make it like it looks like a bit like a world map there. I'm going to fix that. I got to fix something on this thing.